When you get a brand new CNC router set up, the first thing you have to do is surface the spoil board. In this video, I'm going to show you exactly how to set yourself up to surface your spoil board on your CNC router the right way. idcwoodcraft.com. I'm Garrett, CEO of IDC Woodcraft, the company that you get your CNC router bits from. And in this video, I'm going to walk you through the steps to surface the spoil board on your CNC router so that when your machine carves, it carves the right way. Now, what is the spoil board and why do you need to surface it? Well, the spoil board is this whole surface here on the CNC router where your project is set down so your CNC router can actually do the carving. And if the spoil board is not level to the motion of the machine, then your carves are going to come out uneven and not looking very good. And this is why we have to surface our CNC routers before we carve anything. So I'm going to show you how to set yourself up to surface your spoil board the right way. Now, one thing I want to point out before you start to surface it is you need to make sure that your CNC router is trammed in. Now, what does tram mean? Tram is the spindle axis of your machine is perpendicular to the level of the spoil board. You're going to do what we call a pre-tram cycle where you're just going to make sure that the spindle axis is perpendicular. Now, what I mean is a machine that's out of tram, we'll pretend this is the axis of the spindle here. If the machine is out of tram, the axis will be leaning over like that, or like that, or back or forth. And when it actually does its cutting, it will actually leave steps in the spoil board and it will leave steps in your project. So you always need to tram first. I've created a video that shows you exactly how to tram your machine. I will link that down in the description and there will be a flag that'll pop up here right now. If you haven't trammed your CNC router, you need to do that before you surface your spoil board. So make sure you watch that video first. Okay, so now when you're setting yourself up to surface your spoil board, I want to set the stage here. On your CNC router, you either have a homing sequence in your machine or you don't. And you'll know that when you have what we call homing switches. And we look over here on the machine, my alt mill CNC router, there's a little sensor here. And this is going to be on all axes of the machines. Those are homing sensors, so I have a homing sequence. If you don't have a homing sequence, you're still going to follow the procedures I'm going to show you, but I'm going to make sure I clarify how to do this if you have a homing sequence and if you don't have a homing sequence. Now, the first thing you have to do when you're getting ready to surface your spoil board is know the full stroke of your CNC router in the X and Y. And what that means is the maximum travel that this spindle and the gantry will come from here all the way to the other end of the machine and the gantry from all the way in the back to all the way in the front. I'm going to run through this whole procedure here, but I just want to make sure we clarify that. So let's dive into this, actually start doing this. So we're going to start off with a machine that has the homing switches on it and a homing sequence. And the first thing you need to do is actually send the machine to the home position. So you look at my alt mill CNC router here, the spindle is out in the middle of the work surface, the gantry is forward, so I'm simply going to tell it to go home by telling G-Sender to send the machine home. I click the button and it is moving to the home position. When it stops, it is home. And now that it is at its what we call the machine home, what we want to do is zero our X and Y coordinates at that position. So X is this travel and Y is that travel. And the machine has this nice little hum to it, which is not uncommon for CNC routers. So we want to zero the X and the Y. Simply click on the 0X button and the 0Y button, and you can see now we're set at 0 at the home position of the machine. And so now what I'm going to do, and what you want to do, is to know what is the maximum travel in your X direction and your maximum travel in the Y direction. So if you have homing switches on your machine, then the software is going to be set up for its max travel. In other words, you can bring it all the way over in your X and all the way over in your Y, and it won't bump. It has what's called soft limits in it. And basically the soft limits are built-in limits in the software that will not let the router go any further. And basically it's set up so it doesn't bump into a hard stop on the other side. So I'm going to show you how I do it with this one with the homing switches, and then we're going to go over to the other machine and how I do it if you don't have homing switches on your machine. So basically, we are going to set this to rapid. So the alt mill here uses the G-Sender control software. This is software I really like. It's very user-friendly and nice interface. So we're just going to bring that all the way over. And we're bringing it over diagonally all the way over X and Y at the same time. And I'm holding this down. I'm just going to hold it until the machine stops. Okay, so we're all the way over. And now we're going to look at the control software. And so what it says is my X travel maximum is 49.075 inches. My Y travel is 49.075 inches. So what I'm going to do is I'm going to create a box that is 49 by 49. I'm not going to worry about the 0.075. But we'll get back to that. I want to go over to my long mill CNC router, which does not have homing switches, and many CNC routers don't, so yours probably doesn't. I want to show you how to do that, because if you don't do it right, you're going to hit the hard stop on the far end and you're going to throw off your X and Y. So let's go over to that machine and I'll show you how we set that one up. Now I'm at my long mill, which does not have homing switches. And here's the first thing we want to do. We again want to bring the machine to a corner. I'm going to bring it to the front left corner, and I'm going to bring it over until it bumps into both the side bracket and the front leg. So we're going to just bring it on over in a rapid. Okay, so it now has come to its limit over here on the X travel, and now we're going to bring it forward. Okay, so now we are hard stopped against the front left corner. What we want to do now is you want to change your speed, your jog speed, to a very low speed and just slightly move the machine away from that hard stop. So I've set my G-Sender down to the slowest travel, so it's going to travel at a 0.02 distance on the X and Y. So we're going to move X over once, and we're going to move Y back once, and now we have come off that hard stop. And now we're going to zero the machine out. And now we want to go back to the far left corner. We're going to go all the way over, and then we're going to go all the way back. Instead of doing them both at the same time, I want to actually get my eyeballs on it so I can see this travel. And what we're going to do is we're going to take it so it's just super close to the hard stop, but actually not touching. The hard stop will be this bracket right here that's mounted on the spindle, would run into the side bracket. Okay, so I'm very close, so I'm going to slow that speed down. Okay, and you can see I am very close to that bracket, but just not touching. And that's exactly what we want. And the reason you don't want to touch is because your control software is actually going to think it's still moving, and it'll actually over travel in the control software, but you'll actually be off on the motion of your machine relative to the zero position that you set. So now we're going to bring it back. Okay, that was the wrong way. So now what I did is I actually took it the wrong way and it threw it off. So we actually want to bump again on the Y. There we go. And then I'm going to just put it on a slow travel and bring the Y out and re-zero the Y. So I did exactly what we don't want to do, and that is we actually hit the hard stop and we kept going a little bit, so it threw off the 0 point. So I just bumped it back out just a little bit, and I reset the 0 on the Y. So now we're going to move Y back. Okay, so now I'm going to bring it back, and I just don't want this bracket right here to touch this back leg. So just bring it back a little bit at a time. I'm going to slow it way down. And it's a little tricky to see. I think we've got it. We're good enough. Okay, so right now it's maybe 0.1 away from hitting the hard stop. At this point, now we have our max travel for our Y and our X. And if we look at the readout here, on X, we have 49.075 49.76. So I'm going to say my max travel is 49.5 for X, and for the Y, our max travel is 33.339. So I'm just going to say that's going to be 33.0. And with that, now I can set up my surfacing program. And what I'm going to show you is the way that you do it no matter what type of CNC router you have, but these measurements are the key for the surfacing program setup that you're going to do. So let's get into the design software and I'll show you exactly how we do this. So we have taken these numbers for a very specific reason, and you need to use these numbers for what we're going to be doing. We're actually going to get into the design software and create the surfacing program based on these numbers that we just got. Now I'm going to be using the Vectric design software, which is what I teach on YouTube here. So if you're a Vectric user, then you may want to be subscribing to this channel. If you have any other design software that can generate the G-code, this is going to work for your software as well. The techniques may be a little bit different, but essentially it's all the same. So we're going to do this for the alt mill since it is not surfaced yet. The long mill is, but just follow along with these principles and you'll get it no matter what size machine you have. So the alt mill has a surface area or a cutting area of 49 by 49. And so we are going to create a project area or project size of 49 by 49 in our software. So I've got these numbers already in here just to make sure. 49 by 49, the thickness doesn't really matter, and we're going to say okay. Of course you want to set your job reference point, meaning lower left corner or back left corner, in your setup. The alt mill home position is in the back left corner, so you want to make sure that your origin is set for the back left corner. In the case of the long mill, or if your origin, your home position is in the front left corner, then you need to make sure you set that up. But because I'm doing the alt mill, it needs to be in the back left corner. Now the first thing we're going to do is create a rectangle of the exact same size, 49 by 49, or whatever machine you have that you measured, those are the numbers that you want to use for your rectangle. It's going to be the exact same size as the material. So I'm going to create a rectangle in the software. I'm making sure that my anchor point is the back left corner for this machine. Again, yours may need to be the front left corner. I'm going to set my X and Y origin at 0. And what that means is the rectangle will start at that 0 point in the software, which is relevant or relative to the machine itself. And then we just need to set the size of the rectangle. So I've got 49 by 49, which is already in here, but I'm just going to create it anyway, and we're going to hit create and then close. And so now, if I just select that rectangle, we got it there. So now all we have to do is now go over to the tool path. Now, when you're creating tool paths, one of the things that you absolutely have to do when you're surfacing is you can't just plunge down and start to cut. You need to actually come down and ramp into the surfacing, and here's why. So here is the ultra smooth cutting surfacing bit from IDC Woodcraft. You can see I've used it quite a bit, and this is what we're going to use to surface this machine. You see the cutting blades are just on the outside and there's nothing on the inside. So if you plunge down into it, the cutting blades are going to hit and then it's going to bottom out on this non-cutting area. And that will start to burn, heat up your router bit really fast, and it'll burn the material. So that's why we need to ramp in. And you generally want to ramp in 3 to 4 times the diameter of the bit. So this is an 1.5 inch diameter bit. We're going to ramp in about 4.5 inches. But we need to create the tool path. The first tool path I'm going to create is a profile tool path. And what that means is it's going to come in and it's going to just go around the outermost edges of the rectangle we just created, and it's going to be on the line. And what that means is we created the rectangle line, and that means that the center of the bit is going to be right on the line. So this is the line of the rectangle. It's going to be centered on the line. It won't be inside the line, won't be outside the line. It'll be on the line itself. So the first tool path you want to create is a profile. Now, when you're creating a surfacing program, you want that surfacing to be really shallow. I like to start with a 0.01. It's super shallow. We're going to set it at a very high feed rate which is what you want to do with surface. So the first thing I'm going to do is set my cut depth to 0.01. And we may run the surfacing program multiple times. And then we want to make sure we have the right surfacing bit, which we do, which is a 1.5 inch surfacing bit. We're going to go to edit. We want to make sure that the feed rates are exactly what I want. Now, IDC Woodcraft has a database for the Vectric software, for CarveCo, Carbide Create, and Fusion 360. You can get that off the IDC Woodcraft website for free. And it's going to have all the default settings. And so the default settings we have right now are 120 for the feed rate. The plunge rate default is only 8 inches per minute. And the reason I set that so low is because if you're coming straight down with a surfacing bit, you want to have enough time to stop it for the reason I just explained to you, that you will bottom out on this part of the bit, and you don't want to do that. But because we're going to ramp in, we're going to set that ramp at the feed rate. In other words, it's going to come down to a point and it's going to ramp in at 120 inches per minute and then go on around at 120 inches per minute. Now, I will probably speed this up just because the alt mill is a much more aggressive machine and it's much more solid. As a matter of fact, this machine here for 4x4, $3 grand, which is insane. And it's very rock solid. I haven't actually, I did a test cut on it, a test project just to see how it worked, and it worked just fine, but we got other stuff to do on it, but this thing is solid. And for the price point, I'm very, very impressed with the build on this machine, especially that gantry. That thing is so stocky. All right, so we are set up with a feed rate of 120 inches per minute and the plunge rate at 120 inches per minute, and we are set on the line. And then we're going to come down. We will make sure our ramp, we're going to ramp into it. So we turn on our ramp and we're going to do a zigzag ramp, and I'm going to set that at 4.5 inches, so 4.5. And that's for the ramp distance. And basically what that means is it's going to come over 4.5 inches and come back 4.5 inches as it ramps into the project. And we're simply going to call this profile, which is already named. So I'm going to click OK. And now we created a tool path all the way around a 0.01 deep. So very shallow cut. And because it's so shallow, I'm probably going to double the speed from 120 to 240 as it starts to run. But now we've got to surface the rest of it. Now, when people surface the spoil boards, one of the things that they often do is they do what they call offset surfacing. And there are two methods of cutting, which I'll get into in just a minute. There's the offset and there's a raster. And offset is not the way that you want to surface a spoil board. You want to do it in a raster. So here's the difference. In an offset cut, what it'll do is the tool will come down in the middle. So the machine will move to the middle and it'll come in and then it'll start to spiral outward like that. A raster, it comes to a corner and it goes back and forth all the way across and gradually indexes its way down. And the reason you don't want to do an offset is because when that router bit is coming over and it's getting ready to change directions, it will stop and pause for just a minute before it starts to go the other way. And what you'll end up doing is you'll get in these little burn marks where that paused at. And the reason that happens is because it just pauses just a little bit. And that pause gives it enough time to create a lot of heat in that router bit. And it's just rubbing on the wood. And you don't want to do that. So that's why you want to do a raster. All right, so now we have to do the pocket cut, and that's where this raster comes into play. So you want to set yourself up for a pocket cut. You're going to set your depth to the same, 0.01 deep, and we want to make sure we have the same router bit, which is the 1.5 inch ultra smooth cutting surfacing bit from IDC Woodcraft. I'll put a link down below for that. And then we're going to edit that feed rate. We want to make sure our feed rate is at 120 and our plunge rate is at 120 as well, because we're going to be doing a ramp for that as well. Anytime you use a surfacing bit, you either want to start on the outside of the project and come in and do a raster cut, or you need to ramp into it. Now I've got a video that talks about how to surface your projects. I suggest you watch that, especially if you're new to CNC routers, because it'll give you the proper way to set yourself up for getting your projects surfaced before you carve them, which is something you should always do. So we're in here, and you can see right now I am set up on raster. There's the offset there, there's raster, we want raster, and a climb and conventional doesn't really matter. We want to make sure our ramp is turned on, so you see this little check mark, it says ramp, and I'm going to change that to 4.5. So it'll ramp in at 4.5 inches, and we're going to calculate this. Now you see the name says pocket, that's okay, we're going to go with that. And now if you look at the screen, you can see our entire program. I just want to check one more thing. So, yeah, okay. In the Vectric software, you see this little area, I just went back into the pocket profile toolpath, and the pocket toolpath, and just right here it says profile pass last. I don't want a last or first pass. I'm going to say no pass, and I'll explain what that's going to do. Okay, so here's what's going to happen. The first move is the machine is going to just profile the outside max of that 49 by 49. And then it's going to come in and do a raster cut. Now, in that one section where I just changed from last pass to no pass, what would happen is it would do the raster cut, and then it would come back and do another square cut all the way around. That's a profile pass on the inside of the rectangle. I don't really need that. So that's why I turned that off. So now we have that, and then you want to generate your toolpath. So we're going to close that, and I'm going to save my toolpath. We'll do a quick preview on that just to make sure everything looks good. So do a quick preview of all the toolpaths, and everything looks good. You can't really see anything, but we'll just give it a global color. So what I just did, I turned on global fill, and that shows that this whole thing's yellow. That means it's machining the whole surface. And I'm going to turn that color back off. We're going to close that and generate the toolpath. Now, this program, if you have the alt mill CNC router, I'm going to make available to you. There will be a link down below where you can download this. It'll have a set of instructions so that you know how to use this program. But once we get this generated out, then you'll see exactly how it runs. It'll run the exact same way for you with your alt mill. I do suggest you take a look at that machine if you have this machine here, if you haven't gotten one yet. It's a larger machine, so if you are limited in space, then you know, the alt mill may not be one for you. I like the long mill as well. That's more hobby level. This is more what we might call sub-pro level. And what that means is this has a lot of power to it. It's just not as bulky as what a pro machine would be. And a pro machine is basically a big stocky machine, like the Phantom you're looking at right here, which is a welded machine. It's got a welded frame on it, very heavy, but that's going to cost you $12,000. This one's going to cost you $3,000. Okay, so let's save this toolpath, and we'll click Save Toolpath, and I'm going to give it a name. We're going to call it Alt Mill Surfacing. And then we're going to come into the G-Sender software, and we are going to load the program. And now you can see on the screen exactly what it's going to do. So whenever you write a program, you actually want to just kind of test it out first, especially the first time running. You want to make sure everything's going to work right. So you don't want to dive right into surfacing. You just want to make sure the machine is going to run right. So what I'm not going to do is put the router bit in yet. I'm going to set my Z relatively high. So we're bringing it down. And I'm going to zero out my Z, and we want to make sure that the X and Y is zeroed at the home position, which it is, which you can see right here on the screen. And we're simply going to hit go. So let's test this thing out. All right, so the spindle is coming up, and the spindle is, it takes a little time for the spindle to wind up. Now you can see how fast this machine runs, which is very impressive. So now it is doing the ramp in, and now it's going to go and do the full cut. Now this, at 120 inches, for something like the long mill CNC router or the smaller benchtop CNC routers, this is a good feed rate, but for the alt mill, it's clearly slow. So I'm going to bring that speed up. And our RPMs are set at 12,000 RPMs. So with a surfacing bit, you don't want to go real high, otherwise you're going to burn it up. 10 to 12,000 is what you want to do. If we're going this speed, 12,000 should be good. If you're going slower, you may want to turn it down to maybe 10,000. So it's about done with the profile pass now. Wow, this thing just runs so nice. And it's so much faster than the long mill or the other benchtop routers. So now it is now going into the raster cut. So you're going to see it's simply just going to zigzag back and forth. It'll come over here, it's going to step back a certain percentage of the bit, and then it's just going to keep going back and forth just like that. So we're going to let it run out, make sure everything's running good, and then we're actually going to surface the spoil board. I'll show you how to set that up. Now, whatever machine you have set yourself up in the same way, just different size for your spoil board. And so it's just going to run the same way, except it's going to do it for the size of your machine. Now, one thing is a lot of the different control software like G-Sender here actually has surfacing programs built into them. Now, I'll show you right here with the G-Sender control software. We click it, and now we can set up a surfacing program. I don't like to use those built-in platforms because it doesn't allow me to necessarily have the control I want. Specifically for ramping in, you want to make sure that you have that ramp when you're working with a surfacing bit. Okay, so this thing has run all the way out, and now it's time to actually surface the spoil board. So what I'm going to do is bring the machine back up to the front, and we're going to put the surfacing bit in. I'm going to show you how to set up a surfacing bit on your machine. I know this spoil board is out of flatness relative to the motion, because if you come in here, I did a quick cutout of a project, and you can see these cut marks here going all the way around, but it actually didn't cut through right here. So I know my spoil board is off. I know that my high spot is back here, so I can set my 0 for my Z back there. Now, what I'm going to do is run this out, and we will set this on high speed for the video, but I am not going to have it exposed. MDF is a very fine material, and if you surface it without your dust collection turned on, you're going to fill your whole room with that dust, and you're going to be breathing it in. You don't want to do that. So, all right, so come on up here, and here's how you set up a surfacing bit. You've got this long shaft here. You want to bring your like 2/3 of the shaft into the collet and just leave that much remaining. If you go too far out, which I've seen too many people do, you run the risk of actually breaking the bit or bending the bit, kicking out your project, things like that. So with any router bit, you never want to stick it way out to try to get as much as you can. So let's just tighten this guy up. Oh, here's another thing that's kind of cool about the alt mill and the spindle. The spindle in the alt mill is a thing you can add to it. They give you the option of getting the spindle or not. So I'd always recommend, if you're going to buy the machine, just buy the spindle with it. This is an extra $500, I think. So the machine total is like $3,500, super cheap. Okay, we got that guy in there. We are going to simply zero it out. I'm not going to use the touch plate. I am going to use the paper method just because right now it's much faster for me. We're going to bring that Z down. Now, if you have a touch plate and you're ready to work with it, then you can actually go with that if you want. But here's the paper touch method. It's close, and all I'm doing is just tapping my mouse button. It's moving down at 0.004 thousandths of an inch. There we go. It's touched off. I'm going to zero my Z, and we're going to send the thing back home. And everything is zeroed now except for the Z. Z is up high, and I'm going to hook up the dust collection, and we're going to let this guy rock and roll. All right, the last thing we have to do before we actually run this program is set up our dust collector. This is something I like about the alt mill as well. They've made their dust collection set up really quick. It's this little housing right here that slips right onto the spindle. And let's set it right there. And Basically just tighten it with that. Let's drop that down just a little bit. And it snaps in place, and then I'll bring it back up just a tad. All right, so the router bit is just inside that brush. Now, one of the things with the alt mill, the dust collection boot that they send, it's actually a 4-inch boot. So you want to either have a 4-inch dust collection hose, or you're going to have to adapt like I did. It took me a little bit to figure out how to get reduced to a 2.5, which is what I've already had. So we are ready to rock and roll. Now you hear this little, perhaps in the background, there's kind of this high-pitched buzzing. That's coming from the motors. And those motors are locked right now, which is what you want. Also, what I like about the alt mill is it's got a closed loop system. Basically what that means is the software, the control software that's running the thing, will know if this thing is actually staying on track from the G-code. With machines that don't have the homing switches, they can actually, or doesn't have a closed loop system, if something happens, like it's what they call skips a step with the motors, or something goes off, it doesn't know it, and it'll keep running and it'll carve your project wrong. Okay, with that, we are going to run this thing out and surface the spoil board. Let's go. Okay, just before I actually start this, I want to put just little lines around here. And the reason I do that is so I will know what's been surfaced and what hasn't been. So I'm going to run this multiple times until it gets it all the way across, because it's just a patient process. I mean, you can go deeper on your surfacing if you want, but I like to just keep it nice and shallow. All right, yes. So we did our first surfacing cycle, and you can see that some of the area of the spoil board did not get surfaced. And that's not uncommon. There's a little bit of waviness. It's just there, you know, it's wood, it's gonna be kind of like that. So what I'm gonna do now, and what you would wanna do, is now drop your Z down by another 0.01 and rerun the cycle. And you're gonna do it multiple times until it gets a complete cleanup. So that's what I'm going to do. I'm just going to run the cycle over and over again until I get a complete cleanup across the entire board. Before we actually run the next cycle, my camera guy, Adam, asked me about these little stripes that we're looking on the board here. Now, if your machine is out of tram, what you're going to do is you're going to feel little ridges along here, and you run your finger. It'll just be like little steps. Tram, remember, is the machine is out of tram, it's going to be like that, and as it makes a cut, it's going to be cutting at an angle like that, and therefore the router bit is going to leave little steps in there. It's going to be steps like that, and that's going to be very obvious. You're going to see hard lines along here. So these zebra stripes is basically just where the router bit made it step over and started to come back. The way you can tell if you're very close to being in tram is after you make this first surfacing pass, you can just run your finger along there, and if you're feeling ridges, then you know you're a little bit out of tram. But in this tram video that I have created that shows you how to tram your machine before you surface it, I actually walk through that whole process. What we do is we tram the machine, pre-tram it before we surface the spoil board, then we'll surface it, and then we'll do a final tram. So once I get this surfaced, then I will do a final tram on it, and that's in the tramming video. I'm not going to cover it in this video. All right, let's run this next cycle through until we get all these black marks out of the way. All right, we've got the surfacing done. I had to make 4 passes at 0.01 deep in order to get all the marks off the spoil board. And so now here we are. And the final thing I like to do is just quickly sand over it with like 220 grit sandpaper just to get any fuzzy up. But we are just running our finger across here and making sure there's no ridges on here. You can see the lines, but that's okay as long as we're not feeling ridges. But we double check that with a final tram check. Again, remember to check that tram video. You need to tram first before you start to surface. Now, before I wrap this up, the feed rate I used for the alt mill was 240 inches per minute. I started at 120 inches per minute, and that was too slow for this machine, so we amped it up to 240 inches per minute. The program for the alt mill, again, if you get an alt mill CNC router, which is a nice size 4x4, good, well price range for a CNC router. I'm really liking this machine. The surfacing program is available to you for free. There will be a link down below in the description, and you can just use that, and the instructions will tell you what to do. So basically, we're just going to do a light sanding across the entire thing. Not aggressive, just light, just to break off any fuzzies that might be on here. So now we can feel it. It feels really good. I'll do a final tram check on this, and if it's slightly out of tram, I'll just do a final tram check like I said. Make sure you watch that tram video so you understand how to tram the machine. Again, you want to use a tramming bar, or you can use an indicator like a dial gauge, but that's discussed in the tramming video as well. I like this. It's very quick, simple, basic, and costs a lot less than dial indicators. So remember this whole surfacing thing, the technique we used, we got the maximum travel of the CNC, and then we created our design based on that travel, created a rectangle, had the surfacing bit profile along that rectangle at 0.01 deep, and then we did a raster cut, pocket cut, all the way across. So it ended up doing all these lines like that. And we did it multiple times. We took it down by a 0.01 every time. I had to do it 4 times to get all these marks out. So now the spoil board is nice and level. And then finally you want to sand it off and then do your final tram check. So this program, again, is available to you if you get an alt mill. I do suggest you check this thing out. If you have the size in your shop, the room, and you want a good solid machine at a very reasonable price. Give me a thumbs up if this video is helpful, and subscribe to the channel. I got tons of videos about CNC, walk you through all the stuff, how to design things, how CNCs work, all the micro details that you don't find in any other YouTube videos. So with that, have a great day, better tomorrow, and happy CNC. idcwoodcraft.com